Now tell me again, rocket, whatever rocket is moving up, whether it will be treated as a variable mass system or mass remains constant in a rocket propulsion. Tell me Arnav or Sahat.
Sir, it will be variable.
Very good, variable mass system. You don't consider it as the system in which mass will remain constant. Actually, you know that Newton's laws will be applicable when mass is constant. But here we apply as it is a special case. So Newton's third law will be applied, and in that we treat mass is continuously changing, and thereby we are applying the equation and we are getting these results. Okay. Right. Now let us move to one particular question, which is based on Newton's law of conservation of momentum, and I will explain this particular equation problem, and you have to solve this problem. Second problem, one more problem is there, and that problem you have to solve. Okay, right. So these two questions are of same thing. Same thing is there here. A bullet of mass x units, here also same is there. So a bullet of mass x units is moves with a velocity y units, hits a wooden block of mass z units, which is at a rest, and gets embedded in it. After the impact, the wooden block with bullet in it starts moving. With what velocity does the wooden block and bullet will move? So let me explain with the diagram, and then you can find out the answer here. Now one bullet is there here. One bullet is there like this. A very small bullet is there like this, and this bullet is moving towards a wooden plank like this, and before collision this bullet is coming with some velocity, and this wooden plank is there at a rest actually. So observe carefully, a bullet of mass x units. Let me write like this: mass of the bullet mb I am writing, which is x, moves with a velocity y units. That means initial velocity of the bullet ub I am taking it as y. So mb means mass of the bullet, ub means initial velocity of the bullet is y. It's a wooden block of mass z units. That means mass of the wooden block is z units, and which is at a rest actually. So the initial velocity of the wooden plank will be 0. Why? Because the wooden plank is at a 0, and this bullet is coming and hitting this particular wooden plank, and in this wooden block, whatever is there in that wooden block, this particular whatever bullet is there, that bullet is embedded in it. That means bullet is reached into that wooden block, and after reaching into the wooden block, now what happens is this wooden block with this particular bullet is moving up, and they are moving with some common velocity which we don't know, and we have to find out this common velocity v. How we can find out this common velocity v? Tell me Arno or Sahas. Tell me Sahas, how can we find? By applying what we can find out this common velocity? By applying what we can find out this common velocity? Sahas, are you there?
Sir, not sure, sir.
Even though you are not sure, tell me which law must be used or which equation must be used to solve this. Have you got my point? A bullet is there, small bullet is there. This is a wooden plank, and bullet is coming like this and hitting this wooden block, which is at a rest. Now this wooden block and wooden block is embedded in it. That means it reached into this wooden block, and after that these both are moving like this. When these both are moving like this, commonly moving with a common velocity, and I want to find out this common velocity, with what equation I have to find out it? Arnav, at least you try.
So maybe we will use conservation of momentum, law of
Very good.
conservation.
We use law of conservation of momentum. And what is law of conservation of momentum? Before collision, whatever the total momentum is there for the system, after the collision also, same momentum will be there for a system. Is it right or wrong?
Yes, sir, it's right.
Right. Now tell me, I'll write here clearly.
Yes.
Before collision. Collision means generally hitting only, no? So before collision, I'm writing total momentum. So total momentum I'm writing like this. Can I write like this or not? Tell me. Or now, is it right or wrong? MBUB plus MW plus UW. Is it right or wrong? MBUB is what? Tell me, Arnav.
Sir, X plus one.
MBUB means what generally? What I wrote there? What I wrote there? MBUB.
Sir, MB is mass of the bullet and UB is initial velocity of the bullet.
Very good. MBUB means what? Total.
So total momentum
You
before
have to say like
collision.
this, Arnav. You got it, but you are getting half only. Initial momentum of the bullet. That's it. As UB is the initial velocity of the bullet, no? Isn't it? When initial velocity of the bullet you are writing, it is the initial momentum of a bullet. That's it. What is MUW? Sorry, MWUW?
Initial momentum of the wooden block.
Very good. Initial momentum of the wooden block. That's it. So totally what I wrote before collision, whatever the initial momentum is there for a bullet, initial momentum for a wooden block, totally must be equal to whatever the momentum which is there after collision. That's it. Isn't it?
Yes, sir.
Right. Now, before collision, whatever the momentum is there, that I am writing here. Tell me, MB, mass of the bullet is how much? X. What is the UB? Y. Plus, what is mass of the wooden block? Z. Into,
Z
what is
into
velocity of it? 0. Isn't it? Now, X, Y plus Z into 0. That means 0 only, no? When Z into 0, 0 is there, what will be momentum before collision? X, Y.
Y.
Okay.
Sir, and after collision, since sir they have a common velocity, so sir, it will be the same
Okay,
for
I'm
both.
writing that only. So after collision now, that means after collision, the momentum I'm writing now. After collision, both are embedded in as a one object only, no? Now, how many objects are there after collision? After collision, how many objects are there, Arnav?
Sir, one.
One is only there. What is there? Wooden block. In that bullet is there or not?
Yes, sir.
What will be the total mass now after collision? M1 plus, that means, sorry, mass of the bullet plus mass of the wooden block. These both are commonly moving with one velocity or not? And that common velocity we are taking it as v. So after collision, total momentum will be mb plus mw into v. That means, can I write like this? mb means x plus mw means z into v. Can I write like this or not? Is it right, Arnav?
Yes, sir.
X plus z into v. And our aim is to find out which value here? Common velocity v value. And how we can find out the common velocity here? Before collision, whatever the momentum is there, I am writing before collision momentum will be equal to after collision momentum. That means momentum after collision will be equal to momentum before collision. So I am writing both. Before collision, momentum will be xy, which is equal to after collision. What is the equation for a momentum? X plus z into v. Then we have to find out the value of v. V is equal to xy divided by this x plus z. If it goes to this side, we have to write x plus z. So v will be equal to xy by x plus z. This will be the answer. Okay. Is it clear, Arnav? V is equal to xy by x plus z.
Yes, sir.
Right. And with the same logic, I am giving one problem, and you have to find out the answer. Arnav, Bhumika, maybe you are listening, and I can't find your message here as I'm getting some problem in this particular device. I hope you are seeing it. So I'll try again. But you find the next question. One question I am giving, and based on this question only, same question is there, but with the numericals, we have given one problem, and try to solve it and tell me the answer. Arnav, try it. Arnav, are you trying?
Yes, sir.
Are you finding, Sir Arnav? Bhumika, whether you are trying this problem? Bhumika? Right. Try it and tell me the answer. Two ice hockey players are there. Let us think first ice hockey player as M1 and second hockey player as M2. So see here. First, whatever data is there, that data I will write, and after writing the data, I will tell you hint, and based on that, you have to solve. Two ice hockey players are there, right? Now, first hockey player mass will be 120 kg, and he is initially moving with a 2 meter per second, and mass of a second person is 80 kg, and he is traveling initially with 4 meter per second towards which player? Towards the first player. If we are thinking first player velocity as a plus, then definitely second player velocity will be minus. Why? Because both are coming opposite to each other. Right. Now in which direction and with what speed do they travel after they become entangled? Entangled means both the players are coming like one only. One is embedded in that another person, and they are moving now. So that is what they said actually. So here before collision, now I have to write like this: before collision, what will be the total momentum? That means before entangling. Now what I have to write? Mass of first object. That means mass of a first person into initial velocity of a first person plus mass of a second person into initial velocity of a second person, which is equal to 120 into 2 plus 80 into minus 4. So which is equal to 120 into 2, 240 minus 80 into 4, 320. So which is equal to what I can write? 240 minus 320 means minus 80. Actually, kilogram meter per second will be there as it is a momentum. So kilogram meter per second. This is before collision. That means before entangling. And after entangled. Entangled means both whatever ice hockey players are there, both are connected with each other and they are moving. So that means now we have to write like this: both the persons combined with each other. That means m1 plus m2, and now they are moving commonly with a velocity v. And our aim is to find out this common velocity. So to find out it, momentum before collision must be equal to momentum
Sir,
after collision. Okay, tell me.
sir, I got 2 meter per, I mean, yes, sir, I got 2 meter per second.
Okay, let me find out. Now, momentum before collision is minus EIT is equal to after collision m1 plus m2. m1 plus m2 means 120 plus EIT into common velocity v. Now, minus EIT is equal to 120 plus 80, that is 200 v. So now v is equal to minus 80 by 200. So v is equal to minus 8 by 20. How much it will be? Minus 8 by 20. Whether anybody got this answer?
minus 2 by 5.
Minus 2 by 5. Okay. Minus 2 by 5, how much it will be? Minus 2 by 5. How much it will be? V is equal to minus 0.4 meter per second. So here hockey players are coming like this. This is the first hockey person coming like this. Second hockey person is coming like this, and they are colliding with each other. And after colliding, they entangled like this. And now they are moving in which direction? They are moving in this direction. As you are writing this as negative, so you got negative value only. So in this direction, they will move. So this is about your answer, minus 0.4 meter per second. That must be your answer. Whether you got Bhumika minus 0.4 meter per second. Very good. Do you got, sorry, Arnav, have you got this answer?
Yes, sir.
Milan not there today? Okay. So Bhumika, you got this answer, same answer? Right. Okay, very good. So in this way, you have to apply law of conservation of momentum and you have to find out the answer. Actually, one more problem is there, but instead of that problem, they gave this problem twice. And such problems will be there. And I will give one problem in examination. And you have to solve it and say the answer in an examination. Okay. Have you understood how to apply law of conservation of momentum? Arnav, have you understood?
Sir.
Is it clear? Have you noted down this answer here? Whatever I wrote.
Yes, sir, I wrote it down.
Right. Arnav, have you understood or not? Anything is not understood, you ask me now. I will clarify it and after that we will move into the fifth session. Once you go through it,
Can you
anywhere if you
explain
have any
rocket
problem, ask me.
propulsion once again?
Huh?
Sir, can you explain rocket propulsion once again?
Total,
Yes, sir.
this one,
Yes, sir.
right. Now maybe you know that whenever we apply Newton's laws of motion, generally we think that the mass of the object will remain constant. But in case of a rocket, mass of the rocket continuously goes on changing. How it will change? Just now only I said rocket will be made up of 4 different stages. And in 4 different stages, fuel will be kept. and first stage fuel will be burnt, that will be detached. Second stage fuel will be burnt, and that will be detached. That means when first stage is detached, mass of the rocket will decrease. Why to decrease the mass of the rocket? Why to decrease the mass of the rocket, Arnav?
Sir, because the stage one or the respective stages keep removing because the fuel gets empty.
Okay, I detached first stage. Then what happens actually to the rocket?
Sir, it will become lighter.
It will become lighter. When it becomes lighter, it moves with a more speed or less speed?
Sir, it will move with the more speed.
More speed. And just now only I said how much velocity I have to give to make it to go to some orbit or to escape from the Earth gravitational force. How much velocity we have to give? 11.2 kilometer per second. Remember, how much velocity we have to give?
11 point.
11.2 kilometer per second. Is it very large velocity or very small velocity?
Sir, if we convert it into kilometer per hour, then it would be very huge.
Now also 11.2 kilometer per second. That means in 1 second it has to travel 11 kilometers.
11.2.
Is it possible traveling 11 kilometers in 1 second with ordinary velocities like this?
No,
Even
sir.
bullet train also can't run 11 kilometers in 1 second. Okay, so that much speed we have to give or impart for the rocket. And
Oh
if
my
you keep,
God, I like Chipotle.
huh?
Sorry, sir.
Tell me, Arnav, what you said? I can't hear you. You are speaking with some others. Huh?
No, sir.
Huh? Okay, let me explain. Let me complete it. Okay, right. So to give that much of speed, what we are doing is we are decreasing the mass of the rocket continuously. If mass of the rocket is kept constant, suppose mass rocket will be very big one, and if mass will remain constant, it can't move such a speed. So that's why only it will be made like this. And when variable mass system is there, mass of the system goes on decreasing continuously. And when mass of the system goes on decreasing continuously, we have to use Newton's second law in a particular form only. And if you use that particular equation for a variable mass system, and if you derive relation, you will get this relation. Maybe now you understood. Say Newton's second law can't be applied directly, and we have to apply it for a variable mass system. And after applying to the variable mass system, and if you simplify it, you will get this relation. Which relation? Velocity of a rocket at any time. What is the equation? V is equal to u naught plus Vr into log of base E m naught by m. Is it clear now? At least somewhat concept, Arnav?
Yes, sir. Sir, I didn't understand the true meaning of propulsion.
Propulsion means actually that gases are escaping with very high velocity, no?
Sir.
Gases will come out from the rocket with very high velocity or not?
Yes,
And
sir.
sending the rocket up will be called propulsion. Propulsion means rocket moving up, and it will move because of what? The gases are escaping very fastly. That's why we are calling it with a particular word called propulsion. Okay,
Sir,
is
can
it
you
clear now?
explain inelastic collision also?
Which one?
Sir, inelastic collision.
Here we are not discussing about collisions here. Rocket is moving up because of the way change in mass actually. So we are applying Newton's second law of motion for a variable mass system, and we are finding the equation here. Okay, and in inelastic collision, if you want to say, then definitely in inelastic collisions only law of conservation of momentum will be valid and law of conservation of kinetic energy is not valid. And when bullet is coming and hitting the wooden block, and if it is embedded in it, and if it is moving with a common velocity, that comes under inelastic collision only. That means law of conservation of kinetic energy will not be valid in that case. So few examples will be there for elastic and inelastic collisions. For elastic collisions, I told you, while playing the caroms, when you strike the carom kinds with a striker, that will be elastic collision. Okay. Is it clear,
Yes.
Anu, now?
Yes, sir.
Right. So this is about fourth session actually. To finish this only lot of time took, and now let us move to the next fifth session, and we will learn few things in that, and after that up to what extent we can finish, we will finish it. And I'll take one permission to complete this particular session. Then in next session I'll finish it.